and I thought they looked really good, and I had to get them.
They were.
And they were, in fact, good.
They are dangerously good.
There you go, like, go for it.
Somebody who
Go for it.
Oh, good. The Baja Blast is gone. Yes. All right. Okay. All right. So we had a nice little intro, 30-second intro on this of people getting cookies. All right. Online, everybody can see. Problem 6. Okay. All right. So this is our next one. So it's a finite state machine. It's a sequence detector, and it produces an output of 1 on the clock cycle when the sequence is detected. That tells us this is a mealy. So we want to design the state diagram for this one. So our sequence is 1, 1, 0. So if we start with a 1, well, if we start with a 0, that's nothing, or a reset. If we start with a 1, we can call that state A. State B would be getting 1, 1, and state C would be getting 1, 1, 0. That's actually wrong. Why is that wrong? We don't need a separate state for 1, 1, 0. That just means we've detected the output. We're going to go, that means we're going to go back to another one. We only need to have 3 states. So it doesn't, having 1, 1, 0 means that we got an output of 1, but it's not going to be a separate state. So we're going to see what happens if we're on any of these states. I probably should have called this one A, this one B, and this one C. So if we're on state A, then we've gotten a 0, or we're on reset. We have not made any progress towards getting a 1, 1, 0. If we get from here a 1, we're making progress, so we must be going to a new state. But we don't have our whole 1, 1, 0 yet, so our output is 0. If instead of getting a 1 we get a 0, then we are not making any progress, we're just staying where we are. So we've taken care of state A now. State B means we've gotten a 1, we've gotten our first 1. So we have 1, 1. If we get another 1, we're making progress, so we know that's got to be another state. We don't have 1, 1, 0 yet, so our output is just 0. But if we have a single 1 and we get a 0, and this is all we have. All we have is a 1, 0. Do we really have anything? No. And so that would bring us back to state A. So that'd be if we get a 0, we have a 0. So now if I have a state 1, or state C, I have a 1, 1. I have 2 possibilities. I can get a 1 or I can get a 0. If I get a 0, what state am I now in? I'm in state A, but what's my output? 1. And if I get a 1, what state am I in? C, but what's my output? 0. All right, so now that is a Mealy machine.
So if you get a 1 in C, you go back to A?
You go back to A, but you get an output of 1. No, if you get a 0, you go back to A.
Okay.
1 you stay in C. Okay, so our state table, we have 3 states. We have my input V, I'll say V equals 0, next state V equals 1, next state. But then for my output, since this is mealy, I have separate outputs for the different inputs. So this is V equals 0 output, V equals 1 output. Okay, so if I'm in state A and V equals 0, my next state was A, and if V equaled 1, my next state was B. And if I'm in state A and V equaled 0, my output was 0, and if V equaled 1, my output was 0. If I was in state B and V equaled 0, my next state was A. If my input was 1, my next state was C, and my output was 0 for both of them. If I'm in state C, if V equals 0, my next state is A. If V equals 1, my next state is C. If V equals 0, my output is 1. And if V equals 1, my output is 0. Okay, now the directions say to use a minimum number of flip-flops. So what's the minimum number of flip-flops that we can use? 2. So now I want to do my state assigned table. So I'm going to make A equal to 0, 1. I'll make A equal to 0, 0. I'll make B equal to 0, 1. I'll make C equal to 1, 0. And I have to account for the 1, 1, even though it's going to be don't cares. So A is going to be 0, 0. B is 0, 1. C is 1, 0. And then I have a 1, 1 that's going to be don't cares. Now, there was no method to that. I just went in order. You can do it however you want. Some will be better than others. There's not like a way to know which would give us the best circuit. This is up to you. You just decide how to do it.
So if it was just A and D, it would just be 0 and 1?
0 and 1. Yep. Then I'm going to call the first one of these, I'll call Y1. The second one, I'll call Y0. Okay, so then I have my next state, and I'll use lowercase letters for these. I'll have Y1, Y0 for V equals 0, and I'll have my next state for V equals 1, Y1, and Y0. and my output, I don't know if I gave it a letter, I'll use W. The output W for V equals 0 and for V equals 1. So my bottom row is going to be don't care, don't care, don't care, don't care, don't care, don't care. My outputs are going to be the same. And then we defined A to be 0, 0. So everywhere where I had an A, I'll put a 0, 0. Everywhere where I have a B, I'll put a 0, 1. And everywhere where I have a C, I'll put a 1, 0. Now I'm going to derive minimum Boolean expressions. This usually shows up on the test. Okay, so minimum Boolean expressions. So let's start with y1. And my inputs are big Y1, big Y0, and V. Whoops. And I know when Y1, Y0 is 1, 1, I have don't cares. Right now, I'm doing Y1. This is the part where I usually have the most confusion. So I want y'all to look at what I'm doing. I'm looking at the Y1 column here for my next state. That's Y1. When Y1, I want to see what Y1 is when I'm starting with Y1, Y0 is 0, 0. So that's this column right there. Then when V is 0, Y1 is 0. And when V is 1, Y1 is also 0. As a matter of fact, when I look at V equaling 0, this column right here, I see when V equals 0, Y1 is always 0 except for when it's a don't care. So I know it looks like that.
Can you go over that one more time?
I can. So the way I set up my chart was with the binary numbers. So this is if you look at the chart, I have them labeled Y1, Y0, Y1, Y0. That's because we defined A as equaling 0, 0. That means we're saying Y1 is 0, Y0 is 0. And that's how we defined them. And so we replaced all of these. But we're having to come up with a Boolean expression for the next state. So we're coming up with a Boolean expression for this Y1. Well, what is this Y1 referring to? It's these numbers right here and these numbers right here. That's what Y1 is. How do we figure out what that is? It depends on what the previous state was, so what capital Y1 and Y0 were, and what V is. And so how do I figure out what the next Y1 is going to be? Let's say that I'm currently in state C and V is equal to 0. So state C and V equals 0. Then my next state is A. My next state is A. A is 0, 0. This is Y1, Y0. So my next Y1 is going to be 0. How do I get that from this chart over here? So I'm currently in state C. I'm currently in state C. That means that I'm right here with 1, 0. V equals 0, so I'm in this first column. I'm looking at Y1, which is the first of these variables, and that's 0. So when I'm filling out my K-map, for Y1, I get my Y1 columns from my next states. These numbers across the top, those correspond to these states right here. V equals 0 corresponds to whether I'm here, V equals 0, or V equals 1. So when I'm filling out the V equals 0 row, I'm looking at my next state column when V equals 0. And I see in my next state column when V equals 0, Y1 is 0, 0, 0, and don't care. It's a don't care only when Y1, Y0 is 1, 1. So when Y1, Y0 is 1, 1, I have a don't care, otherwise I have zeros. So now when I have V equals 1, I see that I've got a 0 when Y1, Y0 is 0, 0. I've got a don't care when Y1, Y1 is 1, 1. And for 0, 1, and 1, 0, 0, 1, and 1, 0, I have 1s. And so now I have my Carnot map for Y1. So here's my K-map for Y1, and it looks like my best cover is going to be that. Unless anyone can see something different. And that would be Y0V or Y1V? Yeah. Because they both have a V, because V is 1, and then this group has Y0 equal to 1, and this group has Y1 equal to 1. Okay, so let's do our K-map for Y0. Okay, again, when I look at Y0, this time I'm looking at my second column, because that is Y0. My second column is Y0. And I see when V equals 0, again, they're all 0, except for a don't care at 1, 1. So I get 0, 0, 0. And for this column, I get a 1 for 0, 0. I get a don't care for 1, 1. And I get zeros for the others. So it looks like, so this was Y1. Y0 equals not Y1, not Y0, V.
Will we? Oh, sorry. Will we have to use the asterisk to like denote which variable is the next, or is that all implied like on a test? I mean,
You have to do something to denote it. I'm denoting mine. I don't know if you can tell or not. I'm having my current state with these nice print capitals, and my next state with lowercase little scripts. You have to do something. If you get it right, you're probably in good shape, no matter how you denote it. But if you want to make sure you get all your credit, make sure that you're careful with denoting which is next and which is current.
Alright.
Yeah,
Don't we have to do V?
yeah, I haven't gotten there yet.
Okay, sorry. I know,
Yeah.
I'm on a roll today.
Yeah, you are. Okay, so next we have to do our Boolean expression for V. Okay, so our Boolean expression for V is going to be the same. It's harder for mealy than for more because for more, you don't have to worry about the output, you just have to worry about the current state. But here, we have to worry about the output. So let's see. For V, if I recall, we had don't cares when y1, y0 were 1, 1. So y1, y0, 1, 1, we have don't cares. And we have a 1 at 1, 0, and V equals 0. V equals 0 and 1, 0, we have a 1. Everything else was zeros. So this would be, I could get, yeah, no, that's what I would get. So V equals not, or W, sorry, W. That's our output W. W equals not V, Y1. So then you have your flip-flops. We have two flip-flops. There are D flip-flops because that's what works. And Y1 was Y0V or Y1V. This would be easier to write as V and Y0 or Y1. And Y0 was the not of Y1, Y0, and V. I said that wrong, but this is what it is. So it's the and it was the and of V and the nots of both of these. And W was the not of V and Y1. Oops, this one. And that would be your circuit.
Can you explain V and W? Like go back to the table.
What they are, V is your input and W is your output. So V was our input if 0 or 1. W is just what I called the output.
So what's under, it says output W, what's under that?
V equals 0 or V equals 1 because the output depended on the input. So we had a different output depending, if you look at your table, your input was 1 and your output was 0. Your output depended on the input. So it's the output when V equals 0 and the output when V equals 1.
Okay, I just got confused because it looked like a W. Right.
It does, but that's a V. Other questions?
Could you just go back to the circuit so I can
Yeah, I guess so. Seems reasonable. I am just finishing up, and I'm gonna get some helpers to roll this stuff back, and I'll be done. They are hearing me right now say, we're done. What's that? You can come upstairs in like 5 minutes. Okay, okay, bye. Okay, what's that?
I said that's a lot for one question.
It is a lot for one question, but it was designed that way to cover a lot of concepts in one. But in most tests that I've seen in 2742 on the midterm, there has been not necessarily draw a circuit, but derive a minimum Boolean expression for something. And so you kind of have to go through everything to get there. It's usually not a terribly difficult circuit. Like this one was not a very difficult state, in some years there have been some where you have like 2 inputs, and so if I get a chance I'll try to make a video for that, but I don't know if I will. Okay, so you're welcome. For those of you who are in Zoom, thank you. Anyone who wants to help me put back things that were not here when I got here at 3:30, I would appreciate it. And thank you, Zoom people. Have a good evening. Study well.